Okay, so we're getting into finding equations of lines, graphing lines, and finding slopes of a line or a slope between 2 points. And so let's look at the following. Oops. Okay. So slopes talks about steepness of a line or a curve. We're going to just be talking about lines in this class. So the following says, when you walk upstairs, there is a certain steepness to them, right? The steepness can be calculated by using the term slope. Slope is the numerical measure of the steepness of a line and can be found as follows. So basically, if we looked at the step, we look at how much we're running over, how wide is that step, and then how high are we going? We look at that steepness there, that line that would form it. If we put maybe a plank on the steps, that would give us how steep that the stairs were. Okay, so definition. Let's say we have a point P and let's call it x sub 1, y sub 1. Let's say we have some point Q and we're going to call it x sub 2, y sub 2. We're going to say that they're distinct points. And in this case, we have to say that our x values can't be the same. If our x values are the same, we have a vertical line. And so the slope m of a non-vertical line containing P and Q is defined by the following formula. So when we're looking at this, we're looking at the change in our y value. So we're looking at one y value, y sub 2, minus our other y value, y sub 1, all over the change in our x value. And so if I start with my point, in this case Q, on top, I have to start with Q in the denominator. So this would be x sub 2 minus x sub 1. If x sub 1 and does not equal x sub 2, then L is a vertical line and M of L is undefined. Okay, so this is there's a little error here. If x sub 1 equals x sub 2, we have the same x value in our point, we know it's a vertical line. Then L is a vertical line and the slope is undefined since the result is divided by 0. So another way of describing the slope is what we had just seen, y sub 2 minus y sub 1 all over x sub 2 minus x sub 1, but it doesn't matter. I could have started with y sub 1 on top minus y sub 2. If I did that, I'd have to start with the first point, my x value on the bottom. So x sub 1 minus x sub 2. Either way, we're going to get the same slope. We say this is the change in our y value over the change in x. And another way to say this mathematically or write it mathematically is this triangle y all over triangle x. That represents the change of y over the change of x. When finding your slope, if you find, and notice that we have it as m equals, m normally represents a mathematics slope, but not always. So if our slope m is a positive number, so if it's bigger than 0, our slope is increasing, or our line is increasing. And if you were looking at the graph, it's rising from left to right. If our slope is less than 0, our line is decreasing. And if you were looking at the graph, it would be moving downwards direction, moving left to right. If your slope is equal to 0, that means our y values had to be the same because 0 over some number is 0. And we said x couldn't be the same. If our slope is equal to 0, the line is horizontal. If our slope is undefined, that means we had 0 in the denominator, meaning our x values were the same, and it is a vertical line. Horizontal lines, they're always going to be in the form of y equals some constant k. If we have a vertical line, this is always in the form of x equals some constant. So if you see, for instance, y equals 3, and if it said to graph this, that is in the form of y equals some number. Another way we can think of this, if we plot points, y is always 3. So it doesn't matter what x is, because technically we can think of this if you wanted to, if it helps you, as plus 0x, right? Anything we plug in for x, we're still going to get that y value of 3. And so if I plug in 1, 2, -1, doesn't matter, 0. So when x is 0, y is 3. When x is 1, y is 3. X is 2, y is 3. Any x value, y is 3. Where if it had asked us to graph x equals some number, so how about -1? So in this case, any number we plug in, x is always -1. And so y can change, but x will never change. And so I have a point at -1, 0, point at -1, 1, -1, -1, -1, 2, -1, 3. And so it's vertical. Okay, so what if it says graph a line that has a point I don't know, -1, 2. And the slope is 3/5. So we were talking about slope as being the change in y over the change in x. Another way that we could have defined this, back up here, is the slope kind of gives us directions how to get from one point to another point, one point on the line to another point on the line. And so you might have heard it as rise over run. So numerator is telling us how much we're going to go up or down, and the denominator is telling us if we're moving left or right. So if I plot the point -1, 2, This is telling me I want to go, well, if I use it as positive 3/5, we're going to go up 3 and to the right 5. So up 3. And then to the right 5. And so that would get us to this point here. I went up 3 from 2. That is going to give me 5. That's my y value. And if I went right 5 from -1, my x value is going to be 4. We can think of it, we can always change our signs. -3, -5, because that's still positive 3/5. So from our point, so we can think of this as down 3 and 5 to the left. So if I went down 3 from 2, that would hit a y value of -1, and then 5 to the right. Sorry, left. Which would give me a point over here. -6, -1. Oops. I'm going to be a little off, maybe because my units aren't the same all the way. Just like that. Okay. So we're looking at graphing the line that has a point to -4 and a slope of 0. So a slope of 0 again tells me that my y value is the same and my line is horizontal. So I would plot my point that it gave me, in this case, to -4. So to the left 2 and up 4. Oops. How about let's change this? I just totally did that opposite. Let's say that was -2, 4. There we go. So our point is -2, 4, and our slope is 0. Horizontal. So a horizontal line through that looks like this. We should be able to go further and find or be able to give the equation of this line. And horizontal lines were always in the form of y equals the constant that horizontal line is going through. In this case is 4. What if it says find the slope between -1, 2 and -1, -2. Well, if you look at this, notice our y values again are the same. And so if I look at, actually not my y values, it's my x values. So let's look at our y values. So we have one y value. So if I use my second point that I wrote out, so -2 minus the other y value, which is 2, all over my x value, -1 minus -1. So this gives us back -4 all over -1 plus 1, which is 0. And this is undefined. We can go further and say this is a vertical line. We even can say what the equation is, x equals, in this case, the x value that is the same, -1. So equations of lines, there's different forms. They're the same equation, but different forms. We have the standard form. That's like if we had a times x plus b times y equals c. Right, B and C are constants. Maybe I should just say real numbers. Okay, we have our slope intercept form. And this is y equals mx plus b. This is the form I prefer just because it helps us with graphing things. M is equal to our slope. And our value b equals our y-intercept. Which, recall, we talked about the last class period, finding our x and y intercepts. If we were finding our y-intercept, if we had set this x value equal to 0, right? 0 times our slope would have been 0 plus b. So it makes sense that that constant is our y-intercept. You have point slope form. So I don't normally use this, but I'm just going to give it to you. This is where we have y minus y sub 1 equals our slope m times x minus x sub 1. In this case, you're given m was your slope, and you were given 1 point on the line, x sub 1 and y sub 1. I tend to, if I'm given a slope and a point, and we'll just look at an example right now, I tend to just use my slope intercept form. Because if I'm given a point and the slope, I could fill everything in here. I could fill in my, let me do a different color, my y, I could fill in my slope, I could fill in my x value, and then I would have an equation with just b left in it. So I could figure out what my y-intercept is. So for example, before we even go to that example, let's even go easier. So if it said your slope is -2 and the y-intercept is 3. Find the equation of the line. We can plug it into this form, y equals mx plus b. We know what our slope is. It's -2. So we have y equals -2 times x. And we know what our b value is. Our y-intercept is 3, so b equals 3. So if we go in here and plug in 3 for b, we have +3. So we have our equation of the line. So let's say our slope we were given is -4 and 2, 1 is a point on the line. Find the equation. Okay, so this is again where I said, and it's okay if you want to use that point slope formula, but we're gonna use our slope intercept form. So we're gonna go in here first and we're gonna figure out what our y-intercept has to be. And so we're gonna do that by going in and plugging in what we have. So I know my y value of my point that was given was 1. This is equal to my slope, which we were given, which is -4, times my x value of the point, which was 2, plus b. So with the point and the slope, we have enough information to figure out what b is. So we have 1 equals -8 plus b. Add 8 to both sides, we get b is 9. So we're not done. We need to figure out what the equation of the line is. Again, if we go back up to our slope intercept form, we can just plug in now what our slope is and what our intercept is. So if we do that, y is equal to our slope, which was -4 times x, plus b, which we just found to be 9. So that just to me is a lot easier. It's in the form that's easier to graph when we do that. I will just show you the other one really quickly, but then if you look at view an example, it might be using this. So really in our case, we have our y₁ value. We have our slope. And we're given the x value of our point, or x₁ value. So if we go back in here and we plug in those values into this equation, we have y minus my y value 1 equals our slope, which is -4, all times x minus 2. So let's clean it up a little bit. Let's distribute our -4 to each term. So we have y minus 1 equals -4x plus 8. Now if we add 1 to both sides, get y by itself, we have y equals -4x plus, well, 8 plus 1 is 9. which is the exact same thing we got here. So either way you want to approach it, whatever's easiest for you, go ahead and do that, but you'll see me using this most of the time. Let's go one step further. Let's say that the homework said they wanted this answer in standard form. This isn't quite in standard form. So remember, standard form, we have both the x term and the y term on one side equals to the constant. So we can quickly put this in standard form by adding 4x to both sides. So standard form of the line, we would have just added 4x to both sides. So we would have had 4x plus y equals 9. So when you're finding an equation of a line, you need two things. You always need a slope and a point. If you're not given those two things, you'll be able to find those two things. So maybe you're given 2 points and you're trying to find the equation of line. Well, we know how to find the equation of line given 2 points, or we know how to find the slope given 2 points, and then we would have our point and the slope. And so let's find the equation of line. Let's say, I don't know, let's make it a little harder with some fractions in there maybe. So 1/2, 2, and 4 -1. So let's find the equation of the line. Again, we want to find our slope. We're going to look at that by looking at our change in our y value. So -1 minus the other y value, 2, all over the change in our x value. Well, I started with the second point, so I'm going to start with my x value 4 on the bottom, minus 1/2. I did it to ourselves, but I don't like the fraction within the fraction. And so let's just simplify our numerator really quickly. And we could write this as a single fraction on the bottom if we wanted to. That's one way to approach it. Numerator is -1 minus 2 is -3. And I'm just going to leave it as 4 minus 1/2 for now. So one way to simplify a complex fraction, which means a fraction within a fraction, is to multiply by our LCD of all the fractions within that big fraction. Well, the LCD is 2. And so I'm going to make a fancy one using that LCD. And so multiplying -3 by 2, we get back -6. I have to distribute this 2 to each term. So 2 times 4, that gives me 8, minus 2 times 1/2, which is 1. So this gives me -6 over 7. Okay, so we found our slope to be -6/7. We're going to need this. And we need 1 point. It doesn't matter which point you choose. Either way, we're going to get back the same equation. I probably would deal with no fractions. So I would probably choose 4 -1. We're going to go in here and we're going to plug it into y is equal to our slope times x plus b. So we're going to plug in our point and our slope, and we're going to figure out what y is. I'm sorry, not y, our y-intercept. So our y value of the point that we chose is -1 equals our slope, which we found to be -6/7, times x, which our x value for that point was 4, plus b. I'm just gonna give myself some more room for her now. So this is -1 equals -24/7 plus b. I can clear my fraction, or let's just think of -1 having the same denominator as that -24/7, because we're going to add 24/7 to both sides. So this -1, right, could be written as -7/7, plus we're going to add 24/7 to both sides to get what b is. Well, 24 minus 7, that is 17/7. So now we know what our y-intercept is. We know what our slope is. And so we can figure out what the equation of the line is. Y is equal to our slope times x plus b. So our slope is -6/7 times x plus b, and b was 17/7. If they asked it for standard form, I would clear my fraction. And so if they asked this to put it in standard form, we could multiply every single term by 7 to get rid of those fractions, right? So if we multiply the left-hand side by 7, we get 7y is equal to, well, 7 times this -6/7, that would, x would give me -6x, plus 7 times 17/7 is just 17. So get the -6x to the other side, we'd add 6x to both sides. So you have 6x plus 7y equals 17. So given 2 points, we were able to find the equation of the line. Okay, so 2 other things we got to look at is parallel and perpendicular lines. Then I think we're going to take a break first. So now we're going to look at equations that are parallel or perpendicular to other lines. In order for it to be parallel, well, if we have parallel lines, they're rising or falling at the same rate. And so parallel lines have the same slope. If they're perpendicular lines, that means that they're intersecting at a 90-degree angle. So you may have something like this. Recall back in geometry, or if you've taken, or we actually looked at it before, but right angles were denoted by that kind of square in the corner. If they are perpendicular lines, the slopes are negative reciprocals of one another. The slopes are negative or opposite sign reciprocals of one another. So for instance, if we had our slope was equal to, let's just say, a over b, the perpendicular slope. So I tend to, so I don't have to write out perpendicular. I remember back in geometry, that perpendicular was that upside down kind of capital T looking thing. So let's write it, perpendicular slope would equal the negative opposite sign and the reciprocal, so flip your fraction. So b over a. Notice if you multiply your slope and the perpendicular slope, you multiply a over b times negative b over a, you're going to get back -1. Okay, so let's look at an example where we're given an equation of a line. So let's say you were given the line x minus 2y is equal to -5. And so find the equation of a line. Let's say parallel to this x minus 2y equals -5 and passes through the point 5, -5. So recall I said that we needed two things in order to find the equation of a line. We need a point, which we're given, and we need a slope. We don't have the slope quite yet, but we can find the slope. We're given that it's parallel to this line right here. This line is in standard form. If we put it into slope-intercept form, y equals mx plus b, then we could figure out what the slope of that line is. And so let's solve here for y. And so we would subtract x on both sides. We would get -2y is equal to -x minus 5. And now let's divide everything through by -2. And so we would get y is equal to, well, -1 over -2. So that's 1/2 x, -5 over -2. So that's plus 5/2. So it's in the form that we should be able to tell what the slope is. Our slope here is 1/2. We know that it's a parallel line, so the slopes are the same. So we know our slope is 1/2. We have a point, 5, -5. And so we could plug this into our equation. Y is equal to our slope times x plus b, and figure out what b is. So I know -5 is equal to my slope of 1/2 times my x value of 5 plus b. So -5 equals 5/2 plus b. So I can get b by itself by subtracting 5/2. So I'm just going to think to myself, getting a common denominator. This is -10/2. And then subtracting 5/2 on both sides is equal to b. That gives me -15/2. So we know what our y-intercept is. We know what our slope is. So we should have the equation of the line. It would be y is equal to 1/2 times x minus 15/2. So graphing those, they would be parallel. So let's look at one more. What if it said perpendicular to y equals 2x minus 3, containing the point and our point is 1, -2. Again, we're finding the equation of the line. So we have a point, we need the slope, but we have the equation it's perpendicular to, and we know that perpendicular lines are negative reciprocals of one another. And so looking at this, my slope is 2. So the perpendicular slope, recall, was the negative reciprocal, so opposite sign, negative. We can think of 2 as 2/1, so flipping that, we get 1/2. So we know what our slope is. We know what our point is. Let's plug it in. So our y value is -2 is equal to my slope, -1/2 times x, which is 1, plus b. And notice again, I'm going to need a common denominator. So let's multiply this -2 by 2/2. So I have a -4/2. But we're adding 1/2 to both sides, plus 1/2 equals b. So b is -3/2. So our equation of the line is y is equal to -1/2 x minus 3/2. Okay, so that is the section on graphing equations of lines and finding equations of lines.